Hello friends, I welcome you on my channel Engineering Mathematics DJ Ganit. Today we are going to discuss about L'Hospital rule and indeterminate forms. So L'Hospital rule is important in evaluating certain limits which we are not able to evaluate by usual methods which we study at school level. So first we will discuss what is meaning of indeterminate forms, and then we will see what is L'Hospital rule and how to evaluate limits using L'Hospital rule. So you are familiar with limits of functions of one variable, and you are familiar with this type of rules of limits. Suppose I have two functions fx and gx, then we know that limit of fx over gx is given by limit of fx over limit of gx, provided the limit in the denominator is different from 0. But if we have some limits like suppose I consider limit x tending to 1 log x over x minus 1. So if I take x equal to 1 here, then I will have log 1 over 1 minus 1. That means I obtain 0 by 0, and this 0 by 0 is undefined quantity, or it is meaningless form. So if we directly substitute x equal to 1 here, then we obtain this undefined or meaningless form. So if we have this type of limits in which by direct substitution we obtain this type of form, then this limit is known as indeterminate form. Indeterminate forms of type 0 by 0, because here after taking x equal to 1 I obtain 0 by 0. So this type of form is known as indeterminate form of 0 by 0 type. Similarly, if we consider this limit x approaching 1 x square minus x over x square minus 1, then also if you take x equal to 1 you will obtain 0 by 0 form. So this is indeterminate form of type 0 by 0. It is not only one indeterminate form. If you have this limit x tending to infinity log x over x minus 1, then if you substitute or if you take x tending to infinity, you will have ln infinity over infinity minus 1. That is, you have this type of form, infinity over infinity. So this is another type of indeterminate form, infinity by infinity. So whenever we have this type of limits, then it is not possible to evaluate these limits by usual methods which we study at school level. For example, we have this limit sin x over x as x approaching 0 is 1. We have proved this in our school level, but for the proof is not easy. We have to use some geometry and so on, but here we will easily prove that this limit is 1. But this is also indeterminate form of type 0 by 0, because after taking x equal to 0 I obtain 0 by 0 indeterminate form. So in general, if we have this type of limit of quotient of two functions, limit of fx over gx. So if I have this type of limit, and if I substitute x equal to a, and if I obtain this 0 by 0 or infinity by infinity form, then we have some ready-made formula to evaluate this type of limits. If we have indeterminate forms of these two types, either 0 by 0 or infinity by infinity, then we have one rule known as L'Hospital rule. So using that rule we can easily evaluate this type of limits, in which either we obtain indeterminate form of the type 0 by 0 or infinity by infinity. So first we see what is L'Hospital rule. So to apply L'Hospital rule, we must have differentiable functions. So suppose f and g are differentiable and derivative of function g is non-zero on an open interval I that contains the point A at which we are interested to find out the limit. And suppose that limit of fx as x tending to a is 0 and limit of gx as x tends to a is 0. That means we have 0 by 0 form. Or suppose limit of fx is plus or minus infinity and limit of gx is plus or minus infinity. That means suppose we have infinity by infinity form. Here sign of infinity does not matter. If you have positive infinity or negative infinity, you can apply L'Hospital rule. If you have minus infinity by infinity, then also you can apply L'Hospital rule. Therefore I have written plus or minus infinity here. So if limit of fx is plus or minus infinity as x approaches a, and limit of gx is plus or minus infinity as x approaches a, then we have infinity by infinity indeterminate form. So in both the cases, limit of fx over gx is nothing but limit of derivative of fx divided by derivative of gx as x approaches a, provided the limit on this right hand side exists. If this limit exists, then it is the value of this limit. Sometimes limit can be infinity or minus infinity also. So we will remember this result known as L'Hospital rule. It is applicable if we have 0 by 0 indeterminate form or infinity by infinity indeterminate form. Now suppose we are, after taking derivatives first time, if we are obtaining 0 by 0 or infinity by infinity form again, then we will apply L'Hospital rule again. That means if we obtain 0 by 0 form here, then we will take second derivatives. So that will be limit of f double dash x over g double dash x. And be careful, here we have to take derivatives of fx and gx separately. In the numerator I will differentiate fx with respect to x, and in the denominator I will write derivative of jx with respect to x. So here we don't have to apply division rule for derivative. We just have to differentiate fx and gx separately. In the numerator we have to write derivative of fx. In the denominator we have to write derivative of gx, and then we will again put x equal to a. If we are getting again 0 by 0 or infinity by infinity form, then we will continue this process of taking derivatives separately of numerator and denominator. So we understand this with the help of example. Evaluate these two limits. So first limit is limit x approaching 0, 3x minus sin x over x. So if you take x equal to 0, then you will see this is 3 into 0 minus sin 0. Sin 0 is 0. So you can see this is 0 by 0 indeterminate form. So we can apply L'Hospital rule. Here fx is 3x minus sin x, gx is x, and both the functions are differentiable at every point. So in the numerator I will write derivative of 3x minus sin x, and in the denominator I have to write derivative of x. So this is by L'Hospital rule. So we have to mention in the bracket whatever result we are applying. Now you must be familiar with derivatives of standard functions. So derivative of 3x is 3 minus derivative of sin x is cos x, and here derivative of x is 1. Now we again substitute x equal to 0. So you can see it will be 3 minus cos 0 divided by 1, that is, okay, we can write one more step. So cos 0 is 1, so limit is 2. So it is easy to evaluate limits by L'Hospital rules if we have 0 by 0 or infinity by infinity indeterminate form. We take second one, limit as x approaching 0, square root of 1 plus x minus 1 over x, square root of 1 plus x minus 1 over x. So here also if you substitute x equal to 0, you will have square root of 1 plus 0, that is square root of 1, which is 1 minus 1. So you can see this is also indeterminate form of the type 0 by 0. So L'Hospital rule is applicable. So here also we differentiate numerator and denominator separately. Here I have to write derivative of square root of 1 plus x minus 1, here derivative of x with respect to x. So this is by, here we are applying L'Hospital rule because both the functions in the numerator and denominator are differentiable. Now derivative of square root of 1 plus x is 1 over 2 times square root of 1 plus x into derivative of 1 plus x, which is 1, and this is 0. Here derivative of x is 1. Now you can see if we rewrite this, it is limit x approaching 0, 1 over 2 times square root of 1 plus x. Now we substitute x equal to 0 and we obtain 1/2. 1 plus 0, that is square root of 1, which is 1 by 2. So in this way it is easy to evaluate limits using L'Hospital rule, provided our functions must be differentiable. So now we take example number 2. We have to evaluate limit of square root of 1 plus x minus 1 minus x by 2 over x square. So if you substitute x equal to 0, this is going to be square root of 1, which is 1, minus 1, and here x equal to 0. So and here if we put x equal to 0, we have 0. So it is easy to observe that this is also 0 by 0 form. So we apply L'Hospital rule. So we take differentiation of numerator with respect to x. Derivative of square root of 1 plus x is 1 over 2 times square root of 1 plus x. Derivative of 1 is 0 minus 1 by 2 into derivative of x, which is 1, over derivative of 2x. In the numerator we have written derivative of x square, which is 2x. Now we simplify this. Here you can see there is a 1/2 common in both the terms. 1 by 2 we can take outside, and in the denominator we have 2, so that will be 1 by 2 divided by 2, which is 1 by 4. and this 1 upon under root 1 plus x is rewritten as 1 plus x raised to minus 1 by 2, minus 1 divided by x. Now we again check by taking x equal to 0. So if we put x equal to 0, we have 1 plus 0 raised to minus 1 by 2, that is 1, minus 1 which is 0, and here there is a x, so it is 0 for x equal to 0. So this is again 0 by 0 form, so we have to again apply L'Hospital rule. So this is equal to now 1 by 4 limit x approaching 0. Derivative of 1 plus x raised to minus 1 by 2 is minus 1 by 2, 1 plus x to the power minus 1 by 2 minus 1 into derivative of 1 plus x, which is 1. Derivative of 1 is 0, and here in the denominator I have written derivative of x, which is 1. Now we can take this minus 1 by 2 outside limit. It is independent of x, so it will be 1 by 4 into minus 1 by 2, which is minus 1 by 8, and this we can rewrite as 1 plus x to the power minus 3 by 2, and if we put x equal to 0, we have 1 plus 0 raised to minus 3 by 2, so this is going to be 1, and we are left with minus 1 by 8, so the limit is minus 1 by 8. Next example, find limit of log x over x minus 1 as x approaching 1. So if we substitute x equal to 1 directly, we have log 1 which is 0 and 1 minus 1 is 0. So this is also 0 by 0 form. So we take derivatives of log x and x minus 1 separately. So derivative of log x is 1 by x, and derivative of x minus 1 is 1 minus 0, that is 1. So this is now limit of 1 by x as x approaching 1, and if we substitute x equal to 1, we have answer is 1. Example number 4. These are simple examples. We have limit of e raised to x over x square as x approaching infinity. So if we take x equal to infinity, we have e raised to infinity, which is infinite over infinity square, that is also infinite. So this is infinity by infinity form, and L'Hospital rule is applicable for infinity by infinity form also. So we now directly apply L'Hospital rule. So derivative of e raised to x is e raised to x, and derivative of x square is 2x. Now we again put x equal to infinity. So it is e raised to infinity divided by 2 into infinity. So this is now again infinity by infinity form. Okay, this form is again infinity by infinity form. So we have to again apply L'Hospital rule. So if we differentiate, derivative of e raised to x is e raised to x, derivative of 2x is 2, and if we put x equal to infinity, then it is going to be e raised to infinity over 2, but e raised to infinity is infinity, so we obtain infinity. So the limit value of this limit is infinite. That means when x is going near to infinity, e raised to x upon x square is also going near to infinity. Next example is limit of log x over cube root of x as x approaches infinity. So first we write cube root of x as x raised to 1 by 3. And now if we take x tending to infinity, we know that log x is increasing function. So when x is approaching infinity, log x is also approaching infinity, and infinity raised to 1 by 3 is infinity. So this is infinity by infinity form. So we have to apply L'Hospital rule. So first we differentiate log x with respect to x. So derivative of log x is 1 by x, and derivative of x to the power 1 by 3 is 1 by 3 x to the power 1 by 3 minus 1, which is minus 2 by 3. Now we can rewrite this as this 1 by 3, if we take in the numerator, it is going to be 3, and this we can rewrite as x to the power 2 by 3 over x, and again we can rewrite this as x1 over x to the power 1 minus 2 by 3. So 1 minus 2 by 3 is 1 by 3, so we have 1 over x to the power 1 by 3, and if we take x tending to infinity, we will have 1 upon infinite, which is 0. This is nothing but 3 infinity raised to 1 by 3, that is 3 into 1 over infinite, and this is 0, so the limit is 0. So these are simple examples in which we are using L'Hospital rule only to evaluate the limits. This is another one, limit of 10x minus x over x cube. So you can see, if we substitute x equal to 0, we have 0 by 0 form. So we differentiate numerator and denominator separately with respect to x. Derivative of 10x is x square x, derivative of x is 1, and derivative of x cube is 3x square. Now if we put x equal to 0, then we have sec 0, which is 1, minus 1, it is 0. So again we have 0 by 0 form. So we have to again apply L'Hospital rule. So now derivative of sec square as x is 2 sec x into derivative of sec x, which is sec x into tan x, minus derivative of constant is 0, and here we have 3 times derivative of x square, which is 2x. So this I can rewrite as, here 2 will cancel out, and sec x into sec x, that is sec square x into tan x over 3x. Now we can again apply the product rule of limits, and we can rewrite this as 1 by 3 into limit of this sec square x into limit of tan x over x. We are applying the product rule of limit. Limit of product of two functions is nothing but limit of fx into limit of gx. So here one function we are taking as sec square x and another function is tan x over x. So if we put x equal to 0 here, we have sec 0 square, which is 1, and this is standard limit. We know that limit of tan x by x as x tends to 0 is 1. Or we can use L'Hospital rule to decide this limit. Here if we substitute x equal to 0, we have tan 0 by 0, so it is indeterminate form. So if we take derivatives, we have derivative of tan x, which is sec square x, over derivative of x, which is 1, and this is now sec 0 square, so it is 1. So the answer is 1 by 3. Next example, here you can see the function in both the problems, both the limits is same, sin x over x square, but here we are taking right hand limit, here we are taking left hand limit. So we are approaching 0 from right hand side and then from left hand side, and we observe whether we are getting the same limit or different limits. So we are deciding the behavior of this function sin x by x square as x approaching 0 from right hand side and x as x approaching 0 from its left hand side. So suppose x is approaching 0 from right hand side, that is we are evaluating right hand limit. So we know that sin 0 is 0. So if we substitute x equal to 0, this is 0 by 0 form. So we can apply L'Hospital rule. So we have to write here by L'Hospital's rule. So derivative of sin x, which is cos x, derivative of x square is 2x. Now here I apply the product rule of limits 1 by 2 constant outside, and I consider this cos x by x as cos x into 1 by x. I consider cos x as one function, 1 by x as another function. So using product rule, limit of cos x into 1 by x equal to limit of cos x into limit of 1 by x. Now limit of cos x as x tending to 0 is cos 0, which is 1. Now what about this limit? So if we substitute x equal to 0, we have 1 over 0. But we have to observe the graph of this function. This is the graph of y equal to 1 by x. It is known as rectangular hyperbola. So now we are approaching 0 from right hand side. That is, we are approaching 0 from this direction. So you can see as x is going near to 0, function is increasing. It is tending to infinite and it is going to positive infinity. So we can write that limit of 1 by x as x approaching 0 from right hand side is infinity with positive sign. So 1/2 into infinity is infinity. Now we take this same function, but we now consider approach of 0 from left hand side, or we approach 0 from its negative side. Here again it is same, all the things are same. This is 0 by 0 form. So by L'Hospital rule, it is limit is equal to limit cos x over 2x. Again we write this as limit of cos x into limit of 1 by x, and limit of cos x as x tending to 0 is 1. So we are left with 1 by 2 into limit of 1 by x as x approaching 0 from left hand side. So again we observe the graph. So if we approach 0 from left hand side, that is from this side, then we can see as x is approaching 0 from this side, our function is tending to minus infinity. So here we have to write this limit as minus infinity. So you can see here limit of sin x by x square from right hand side is infinite and from left hand side is minus infinite. So this is the difference between these two one-sided limits. Both the one-sided limits are different, or we can say that right hand limit and left hand limit are not equal for this function sin x by x square. Next example, limit of this function sec x over 1 plus tan x as x tending to pi by 2. So if we substitute pi by 2, we have sec pi by 2, which is 1 upon cos pi by 2, and cos pi by 2 is 0. So sec pi by 2 is 1 over 0, which is infinite. Similarly, tan pi by 2 is sin pi by 2 over cos pi by 2. So it is also 1 over 0 and infinite. So this is infinity by infinity form. So we have to apply L'Hospital rule. So derivative of sec x is sec x into tan x. Derivative of 1 is 0 and derivative of tan x is sec square x. And here you can see 1 sec x will cancel out and we are left with tan x over sec x. Again, if we simplify this, we rewrite this tan x as sin x over cos x and we keep this sec x as it is. And because sec x is 1 over cos x, we will have cos x into sec x equal to 1. And then we substitute x equal to pi by 2 and sin pi by 2 is 1. So this is simple example. and the last limit is limit of x minus 2x square over 3x square plus 5x. This is rational function. So this we can rewrite as, we take x common first. So we have x times 1 minus 2x over x times 3x plus 5. So this x will cancel out because x is approaching infinity, so x is non-zero, and we are left with 1 minus 2x over 3x plus 5. And if we put x equal to infinity, we have infinity by infinity form, or we can write here it is minus infinity by infinity form, because we have 1 minus 2 into infinity. But it does not matter, sign does not matter, either we have infinity by infinity form or minus infinity by infinity form, we can apply L'Hospital rule. So now we differentiate this with respect to x. So derivative is 0 minus 2, which is minus 2. Similarly, derivative of 3x plus 5 with respect to x is 3. So the answer is minus 2 by 3. So in this lecture we have discussed how to apply L'Hospital rule if we have indeterminate forms of the type 0 by 0 and infinity by infinity. In the next lecture we will discuss some another type of indeterminate forms, and we will see how we can apply L'Hospital rule in those type of indeterminate forms. So I hope you like this lecture, and if you are watching this channel first time, kindly subscribe it for upcoming lectures of each mathematics subject. Thank you very much.